Now 3.2 again is still easy. This is a review from Algebra 2. Question 1. Common logarithmic function has base 10. If you have base 10, we have the common base. Number 2, if you have a base e, then you have a natural base. And this, when you have base e, we have a new notation, Ln. I think you should know this before. Now I would like to go over two formulas. These two formulas, because log base a and the exponential function base a, these two functions, logarithmic function and the exponential function, these functions basically are the inverse function. Therefore, they may cancel out. So like the whole thing, can be cancelled out. Once these two cancel out, the left is x. So this question, well, this question is different. So we have another formula here. How about if I have base a and then the exponent is a logarithmic function? Can I cancel out the whole thing and this one? Yes or no? Yes. Why yes? If you want to know that, I can explain during the class time because this is just a review. So in the video, I will just show you how to use the formula. So this two formula is very easy to use. You simply cancel out two inverse functions, then you have the result. Now number 4, one-to-one property again. One-to-one property. So when you have same function, one input is x, one input is y. How you have these two equal? The only possible is x equals to y, because the logarithmic function is one-to-one function. So one input, only one output. If they have same output, these two are equal. No, I don't suppose to use y again. So this is one function, this is the other function. If these two functions equal, then the input need to be equal. I can show you another way of the calculation. Say, if the given you have ln x equal to ln y. Now, let me choose other color. If I consider pretend they are the exponent to the same base e, then what happens? Because these two are the inverse function y, ln equals to log base e. Okay, let me choose the right color. So this means log base e. This one log base e. Therefore, e to the log base e, they may cancel out to each other. So if we have e here and the e there, they may just cancel out. Okay, cancel. So by this way, I can do something here. So this one and this one are inverse function. This one and this one are inverse function. So what do we have left? X equals to y. So this is number 4. Number 5. So basically, we call this called rewrite. Or you want to write this is exponential equation and change to logarithmic equation. Now, logarithmic equation, this here you need to put here you need to have a base here, and the output, this output, this we call output. And what's the input? The input is here, right? So as long as you memorize the right location, then you can do it right. So the base 81 goes to here, and the input was the output before, right? This output, because they are inverse function, so output become input, and the input here, this is the exponent was the input before, become output. And this is the base. Base is 81. Base is always on this location. So that's how we call rewrite. We don't solve for anything. We just rewrite from exponential equation to become logarithmic equation. Let me erase all my writing, make it look easier to read. This is easy. I don't need to write down so many things here. Okay. Number 6, same idea. This is an exponential equation. So the base is 2, and the result, the output become input here, and the input is the exponent. Exponent become the output. Number 7, evaluate. You change x to 7. If you want to use calculator, that's okay. But if you want to hand calculate, this one a little hard, but not too hard. 7, you want to change it to base 49. How can you change 7 to base 49? Square root of 49 is 7. Or you say base is 49, exponent is 1/2. So we would like to have the same base. If you have same base, then you can use the formula. These two cancel out. So your answer is 1/2. Number 8, similar idea. You want to change square root become degree 1/2. So square root means degree 1/2. and then we may cancel out base and cancel out the base with the whole thing. Then we have the answer 1/2. Number 9. So they provide the function, and you simply provide the function here, and you simply plug in this x to the function. Now, a fraction 1/600, you can change it to exponent, right? Now, there's another formula. If you have a exponent inside the log function, you may bring this -1 degree to become multiplication. So it means -1 multiply. So this number will be here. That's another formula you're supposed to learn from algebra 2. Now you may just use calculator to find this number and round your answer. Number 10. Number 10, you may just cancel out the inverse function. Its answer is easy. Number 11, same idea. These two, yeah, you use 1-to-1 property because log base a equal to the log base a, so the input x minus 6 should equals to input 2. So you solve for a. Now there's one thing very important is you need to make sure the input x minus 6 after you find the x equal to 8. This number need to be positive. Can never be 0, can never be negative. And these two already positive, so no problem. And here 8 minus 6 is positive. So it's okay to keep this solution. It's okay. Okay, it's fine. Now next one. Number 12. Remember last time, 3.1, we talked about the shifting for a function. The number x take away is 3. Let me change color. So the number x take away is 3. So part 3 means you shift this graph to right hand side 3 steps. Okay. And then when at that time your parent's function means you don't take away 3, you don't plus 5. So your parent's function will be y equals to this. Now your parent's function you need to memorize. And then the parent's function have a asymptote is x equal to 3. Now if you shift to right hand side 3 steps, so we say h equals to 3. Therefore, your asymptote need to plus 3. So your new asymptote will be x equal to 3. That's because of the after the shifting. And then from your parent's function, you're supposed to have 1, 0. But because your x shift 3 units, so 1 plus 3, you have a new important point here. So this point plus 3 become 4, 0. And afterward, you need to plus 5 go up. So you push the whole graph 5 steps up. Now this y value need to plus 5. So 4 has no change, but this 0 become 5. Okay. So that's how we have the new graph here. Now, how we decide the domain? The domain will depend on the x, and your x value from the parent function, x is positive. Right now is x greater than 3. So your domain is from here, x greater than 3. Okay. Now, if you try to find x-intercept, what's the x-intercept? I don't think they will ask you to find x-intercept. So if x-intercept you want to make y equals to 0, and then you try to solve for x. You don't need to do that. I think I did something extra for my own homework. So you don't need to do this part. Okay? Number 13. So here is the question for number 13. Number 13, there's a given function. The given function by the logarithmic function. Can you rewrite to become exponential function? Now, you want to pay attention. Ln means base e. So the base is e. When you have base is e, and what's your exponent? Your exponent is the output. So this is base. And this exponent. Exponent will be here. This is the exponent. Okay. And the input become output. So this is the rewrite form. Number 14. Base is e. When you have base e, you may rewrite the base e function to look like ln. And the input need to be the original output. Exponent will be the output for the logarithmic function. So you need to write down in the right location. Number 15. 4 multiply a logarithmic function. What's the input? 0.34. You simply use calculator to do it. Number 16. The parent function. What's the parent function? Let me write down for you. The parent function is supposed to be y equal to ln x. Now, the new function is x minus -6. Plus 6 means minus x6. So you shift to left-hand side 6 steps. So the original graph should shift. So original parent graph shift 6 steps. So by doing this, the original asymptote shift to the left-hand side 6 steps. Now, so say this is the parent function. You have 1, 0, and the take away 6 become -5, 0. So you take away 6, so you have -5, 0. That's how you have this one. And this asymptote, x equals to 0, you take away 6. 0 take away 6, you have x equal to negative 6. So the asymptote 0 minus 6. Okay. So that's a new graph. And the domain talking about what's the x. This is the asymptote for the new function, and the x need to be on the right hand side of the negative 6. So x greater than negative 6. Number 17. Number 17. Okay. So you have same logarithmic function, and if these two functions need to be equal, you need to have same input. So this question actually is easy. The input need to be equal. And then we solve for x is positive negative 2. Now remember, the input for the logarithmic function need to be positive. So 2 is already positive. 2 is already positive. There's no problem. But we need to make sure this one also positive. If x equals to 2 or positive or negative 2, you want to plug in to here to make sure this is positive and yes. So we keep these two solutions. Oh, last question. This question kind of hard, so let me spend a little time to explain. They already provide you the equation between t and L and k. Let me read the question first. A principal P invested at the rate and compounded continuously. Remember at 3.7 section, I told you there's a exponential function to talk about compound continuously. Now, according to this question, they said after t years, the principal become k times. If the principal become k times, we may cancel out the p. We divide by p on both sides. We may divide by p. If you divide by p, so you cancel out the p, right? Therefore, you have simplify, and then you can find the equation. So this equation I solve the formula for you, which is this one. Same thing. So these two are the same thing. Okay, I show you the work. Now, obviously, if you increase k here, if k increase, t will be increased. If k decrease, t will be decreasing. That's obvious. So that's what it talk about. So k increase with k. Oh, sorry. The number of year t will increase with k. So let me explain the grammar for you. The number of years t increase with k. However, this part answer kind of hard, so I try to explain. The larger the value of k, the fewer the years required to increase the value of the investment by an additional multiple of the original investment. Typically, it's talking about if the k is larger, means the growth is faster. When it grows faster, then it may require less years to grow larger. So that's what it means. Okay, you can spend time to think about the meaning. And if you still have question, I will explain more time, one more detail during the class time. Now, we want to graph the original function because the original function here is increasing function. So if the origin function is increasing function, these two are the increasing function. Which one is the right one? You may use your graphing calculator to graph. Okay. So this all we have for 3.2. Thanks for watching. See you next time.